For centuries, man has relied on the map to guide his travel, mark his global position, and define his territory. Mapping the land developed as a graphic form of recording its physical features. From there, maps had to then be refined to show the demarcation of areas of land. This was done using astronomical sightings in conjunction with the mathematical measurements of property boundaries in a process that became known as surveying. Surveying became very important as settlement increased. More accurate records about boundaries had to be maintained as the land was divided into smaller holdings. In British Columbia, settlement began in earnest in the 1860s. At that time, all the land was held by the Crown, and after Confederation, the province assumed the responsibility for administering it. To this day, as part of this mandate, the lands component of the Ministry of Forests and Lands maintains accurate textual and graphic records about the Crown land base of British Columbia. It is this continuity of information that is the fundamental purpose for the Crown Land Registry Information System. This presentation will examine the graphic portion of the Crown Land Records, how the Ministry has moved from manual record keeping to automated mapping, and how the same information will be handled in the future. Beginning with the initial settlement of the province and continuing for over a century with only moderate change, the manual recording of Crown land survey data produced a series of 729 ministry reference maps. These maps were maintained and updated entirely by hand, including redrafting and replacement as required by physical wear. In 1979, with the advancement of technology and the increased demand for use of Crown land, the Ministry decided to regionalize land administration and automate the textual registers and reference maps. In 1980, the Ministry installed the Intergraph design system, and work began to enter the multi-scale map information from the original 729 reference maps into the computer. But it quickly became apparent that simply digitizing or tracing the old maps would not produce satisfactory results. After some initial experience with the system, the Ministry recognized that the system's capabilities went far beyond that of a convenient drafting device. By using source documents properly, the system functions as a graphic database. The Ministry has now standardized mapping using the British Columbia Geographic System at the 1 to 20,000 scale to gain precision and allow unconstrained exchange of map data with other resource agencies. The Ministry now receives digital base map information from the Ministry of Environment. Each map sheet is bounded on the north and south by lines of latitude 6 minutes apart, and on the east and west by lines of longitude 12 minutes apart. For easy indexing, these sheets are clearly defined within the National Topographic System and can be further subdivided for larger scale mapping. The graphics system will also serve as an index to information about unsurveyed Crown land and illustrate the basic survey structure of BC. Digitized reference maps show the location and extent of the existing surveyed lands so that the new surveys can be managed, old survey parcels can be redefined and subdivided, and some records of survey field books and plans can be cataloged. Eventually, the graphics system will provide online access and input by remote users as part of the ministry's decentralization. By then, the digitized information will be accurate enough to act as a database for generating legal document sketch plans for regional use.
I'll be right back.
But most importantly, the graphics system provides a secure and durable format for storing map information. The graphics system is used to describe the spatial extent of a parcel or area of Crown land. Two original sources of graphic information make up the system's database: the official survey plans and the official hand-drawn reference maps. The content and format of the graphic records are specified by the Surveyor General's regulations governing cadastral surveys. The official survey plans represent the primary survey structure of the province and form the foundation of the database. Plans describe parcels of Crown land. Altogether, the Surveys and Lands branch of the ministry maintains over 120,000 survey plans. 60,000 of these are official Land Act survey plans. The number of Land Act plans increases by approximately 1,200 annually as new surveys of Crown land are completed. The remaining 60,000 of these plans record land transactions such as Land Title Act subdivisions. The official survey plans form the basis for the development of the official reference maps. The official reference maps represent a composite of survey plan, topographic, cadastral, and political boundary information. All this information is superimposed on the digitized base map supplied by the Ministry of Environment. Determining a schedule for what reference maps will be produced has taken careful planning in cooperation with the field offices of the Lands Division and the Ministry of Environment. An average of 470 maps are produced annually. The field offices supply relevant background information to the Surveys and Lands branch, where it is incorporated into the reference maps. As encumbrance information is updated, the maps are easily revised in both the automated and hard copy formats. The most important feature of the graphic system is that the automated format for cadastral reference maps can be updated and corrected instantly to reflect the most current information. The official reference maps contain the graphic representation of various types of surface rights, such as Crown land that has been transferred to private ownership, Crown land reserved for disposition, areas designated for specific use, and areas that other government agencies may require. The maps also contain the cadastral and planimetric features, such as Land Act subdivisions, mineral claims, all known surveyed and unsurveyed roads, railways, utilities, easements, file numbers, and survey control information. Like all computer systems, the Intergraph design system is made up of hardware and software. The 8 graphic workstations are controlled by the VAX Central Processing Unit. Because of the need for a vast memory, all the graphic information is stored on both tape and disk. Base map information from the Ministry of Environment arrives in tape form, compatible to this system. Printed maps or hard copies are produced by a map plotter that reads the numerical digital information and translates it into graphic form. A complete reference map that once took anywhere from 3.5 to 5 days to draw manually can now be plotted in about 20 minutes. In conjunction with the hardware, there is, of course, the software that plays an integral part in the graphic production process. The main software is the Intergraph Design System's graphic production package. As well, the ministry uses software for specialized applications such as the Gridder program for map sheet construction and the SUR 200 program, which automatically places the survey control monuments in the design file. When the Ministry of Forests and Lands map-making operator starts work on constructing the cadastral level of a map sheet, she will start with a planimetric base map, usually in digital form. The base map illustrates visible, natural, and man-made features related to the Earth's surface by survey control monuments. The operator begins by entering the survey control monuments. She will then look at the original cadastral survey documents, including right-of-way plans, subdivisions, retracement surveys, and original field notes to determine which plans relate to the existing survey control. The operator's next task is to enter the cadastral survey information, the lines that define a parcel, into the base map. This is the foundation for displaying the reference information and requires considerable judgment and experience on the part of the operator. The original cadastral survey system consists of a multitude of separate surveys carried out over the past century by many different surveyors to various standards of accuracy. These surveys were built one upon the other, mostly without overall survey control, so constructing a cadastral map to a standard geographic base is not an easy task. The mapping software gives the operator the ability to rapidly and easily adjust errors. Once an error has been adjusted in any given chain of survey lines, the operator can proceed to build other parcels out from it until she's coordinated all the cadastral corners on the map sheet and digitized any natural boundaries. The computer combines mathematics and electronics to convert numerical data into a graphic representation. The Intergraph Design System's design file provides the electronic means of establishing the relative position of map features. When an official reference map has been completed, the design file holds the combination of all active design levels for that map. Specific design files can be combined to produce maps for particular themes. For example, forest tenures, mineral and petroleum tenures, reserves over crown land, cadastral or planimetric information. The relative positions of cadastral or map features are accommodated by defining all positions in terms of a plane coordinate or XY grid system. The map features are positioned in relation to geodetic survey control points, which can be expressed in terms of plane coordinates. 2 or 3 control points per source document are sufficient to determine the orientation of the plane coordinate grid in relation to the map. The system can handle specific requirements, such as locating well sites or coal license boundaries using the petroleum and natural gas grid. The system can focus on any section of a map at the command of the operator and can even vary hard copy output, including map scale. Any combination of data contained in a reference map can now be generated to suit particular needs. The database is both powerful and flexible. The graphic portion of the Crown Land Registry Information System will continue to be improved to better support the cadastral survey structure of the province and offer new ways for users to access and manipulate increasingly precise information. Soon the textual and graphic systems will be automatically integrated by a process known as georeferencing. This will allow users to call up associated written data about an area as well as the map. Eventually, the graphic system will include automation of official plan information as part of the verification process. This in turn will lead to official plan data serving as a component in the automated reference map construction process. And somewhere in the future, the system will incorporate the global positioning system of surveying for all cadastral parcels within the province. Global positioning allows the user to compute survey data at the site, which simplifies the job for field personnel. With field data this accurate, the reference maps will be able to identify legal boundaries with the same degree of accuracy as the official plans. Ever since the inception of mapping and recording the information about Crown land, the objective of the system has always been to enable the landowner to precisely demarcate the physical extent of his land holdings. The ministry now takes advantage of technology to meet that objective. It is this technology that will allow the ministry to continually improve its service to the public.